How to wire a ring circuit. Complete step-by-step guide for learners. A ring circuit, often called a ring final circuit, is one of the most common socket circuits used in domestic electrical installations, particularly in the UK. For apprentices and learners, understanding how to wire a ring circuit correctly is essential because it forms the backbone of most residential socket outlet installations. In this guide, we will cover what a ring circuit is, why it is used, materials required, step-by-step wiring process, how to test the circuit, common mistakes to avoid, important safety considerations. Important, always carry out safe isolation before working on any electrical installation. Ensure the supply is isolated, locked off where required, and proven dead using approved testing equipment. What is a ring circuit? A ring circuit is a socket circuit where the cable starts at the consumer unit, loops through each socket outlet, and then returns back to the same protective device, forming a complete ring. Unlike a radial circuit which ends at the last socket, a ring circuit returns to its origin. This means the current can flow in two directions around the ring, allowing the load to be shared between both legs of the circuit. In typical domestic installations, a ring circuit is wired in 2.5 square millimeter twin and earth cable. ETLA is protected by a 32 ampere M CB or RCBO, supplies socket outlets, area typically up to 100 square meters. Because the current divides between both legs of the ring, the circuit can safely supply more sockets than a comparable radial circuit using the same cable size. Why are ring circuits used? Ring circuits were introduced to make efficient use of copper while allowing multiple socket outlets to be installed on a single protective device. The main advantages include 1. Efficient use of cable. 2. Higher load capacity compared to a 2.5mm radial. 3. Flexibility for domestic socket installations. However, ring circuits must be installed and tested correctly. A broken ring can lead to overheating if undetected. Tools and materials required. Before starting, gather the necessary tools and materials. 2.5 square millimeter twin and earth cable, 32 ampere MCB or RCBO, socket outlets, back boxes, metal or plastic, consumer unit, earth sleeving, cable clips or containment tools, insulated screwdrivers, wire strippers, side cutters, voltage indicator, proving unit, multifunction tester, lock-off kit. Never begin work without proper tools and approved testing equipment. Step 1. Planning the circuit proper. Planning is critical. The cable route should start at the consumer unit, travel to each socket outlet in turn, return to the same protective device. Follow safe wiring zones. Avoid unnecessary joints. Sockets should be positioned according to design requirements and regulations. Ensure cable routes are either vertical or horizontal from accessories and within prescribed zones. Avoid sharp bends and excessive cable lengths. Step 2. Installing back boxes. Install back boxes at each socket location. Ensure boxes are securely fixed. Depth is suitable, usually 25mm or 35mm depending on installation. Cables enter through appropriate knockouts. Grommets are fitted where required. Leave enough cable length inside each box for termination. Step 3. Running the cable. Run 2.5 square millimeter twin and earth cable from the consumer unit to the first socket location. At the first socket, bring one cable in. Run another cable out to the next socket. Continue this process until you reach the final socket. From the last socket, run the cable back to the consumer unit to complete the ring. You should now have 2 2.5mm cables at every socket. 2 cables returning to the consumer unit. Avoid joints in inaccessible locations. Maintain neat cable runs and secure cables appropriately. Step 4. Wiring the socket outlets. Each socket will have 2 cables, one incoming, one outgoing. Strip the outer sheath carefully without damaging insulation. Inside the socket, brown conductors go to live, L, blue conductors go to neutral, N, green/yellow, CPCs go to earth, E. You will terminate 2 lives into the live terminal, 2 neutrals into the neutral terminal, 2 CPCs into the earth terminal. If the back box is metal, ensure the earth fly lead connects the earth terminal to the back box. Make sure no copper is exposed, screws are tight, conductors are fully inserted. Repeat for every socket. Step 5. Terminating at the consumer unit. At the consumer unit, you will have 2 lives, 2 neutrals, and 2 CPCs for the ring circuit. Connect both live conductors into the 32 ampere MCB, both neutral conductors into the neutral bar, both CPCs into the earth bar. Ensure conductors are correctly identified and securely terminated. Do not energize yet. Step 6. Testing the ring circuit. Testing is one of the most important stages. Before energizing, carry out dead tests. 1. Continuity of ring conductors. Disconnect both ends of the ring at the consumer unit. Test live to live, neutral to neutral, CPC to CPC record resistance readings. Live and neutral readings should be similar. CPC reading will be slightly higher due to smaller conductor size. 2. Figure of 8 test, R1 plus Rn. Cross-connect live and neutral at the consumer unit. Measure between live and neutral at each socket. Readings should be consistent across all outlets. This confirms the ring is complete, no breaks, no interconnections. 3. Insulation resistance test between live and neutral, live and earth, neutral and earth. Ensure readings meet minimum regulatory requirements, typically 1 megohm minimum, but ideally much higher. 4. Polarity. Verify correct polarity at each socket. 5. Earth fault loop impedance. After energizing safely, measure Z's to confirm disconnection times will be met. Common mistakes to avoid. 1. Broken ring. If one leg becomes disconnected and goes unnoticed, the circuit becomes a radial but still protected by a 32 amp breaker. This can overload the cable. Testing prevents this. 2. Loose connections. Loose terminals can cause overheating and arcing. Always double check tightness. 3. Overloading spurs. Unfused spurs should supply only one single or one double socket. 4. Mixing conductors. Never mix ring conductors from different circuits. 5. Ping testing. Energize without full inspection and testing. Spurs on a ring circuit. A spur is a branch taken from the ring. Rules. Unfused spur equals one single or one double socket only. Multiple sockets require a fused connection unit, FCU. Spurs must not create a second ring. Spurs should be planned carefully to avoid overloading. Safety considerations. Electrical work carries risk. Always isolate supply, lock off, prove dead, use insulated tools, follow current wiring regulations, complete certification, never work live. Inspection. Checklist. Before energizing, check correct cable size, secure terminations, correct protective device rating, proper earthing and bonding, no visible damage. All tests completed and recorded. The understanding load distribution. In a ring circuit, current divides between both legs. For example, if a load is positioned midway, the current splits roughly equally. If a ring is broken, the current flows only in one direction, which can overload that section. This is why proper continuity testing is essential. Certification. Once installation and testing are complete the appropriate certification such as Electrical Installation Certificate, EIC, Minor Work Certificate, if applicable. Record continuity readings, insulation resistance, polarity verification, ZS values. Accurate documentation is part of professional practice. Final thoughts. Wiring a ring circuit correctly requires careful planning, neat installation, correct termination, thorough testing. Proper certification. For learners and apprentices, mastering ring circuits is a fundamental skill in domestic electrical installation. Remember, a correctly installed and tested ring circuit is safe, efficient, and reliable. But a poorly installed or untested ring circuit can be dangerous. Take your time, follow procedures, never skip testing. Electrical work is not just about connecting cables, it's about ensuring safety and compliance.